Reminder that we have a test coming up. Our test is on September 4th, which isn't that far away, okay? So be preparing for that test. There are some old exams. If you want to start practicing some of those online, you can take a look at those and practice. The solutions are online too. Right, September 13th. Exam 1. September 13th. Yeah, not the 4th. It's on the 13th. But it's not that far away, okay? So just be prepared for that. Make sure that you're preparing for it now. It's much better if you prepare every day for 10 or 15 minutes than to wait a couple days before the exam and start preparing. You do have an OpenStax tutor assignment due on Friday. That's a homework assignment. That's important or not important? It's very important. So do as well as you can on that. You can use any resource that you want. There's another assignment due on Monday. It's a reading assignment. Important or less important? Less important. It's extra credit. In the end, it'll count towards about 10 extra credit points, which isn't that much, but it'll help some of you. All right. I want to pick up where we left off last time. We were talking about the standards of measurement, the kilogram, the meter, and the second. We'll be using the MKS system in this class. And we'll also be using a lot of metric prefixes. And so you'll need to know what the metric prefixes are. I won't provide these to you, but you need to know what they are. Particularly, you're responsible for these. But in particular, ones that we'll use a lot are centi, kilo, milli, and micro. So in particular, we'll use those a lot. Later, next semester, we'll use the smaller ones, the nano and the mega and the giga as well. But you need to know those metric prefixes. And later, we'll learn how to convert between different kinds of prefixes from one to another. You should have seen these before, but in short, milli, for example, a millimeter is abbreviated like that. This is the abbreviation for milli. So here, this means milli. This means meter. And what it means is that a millimeter is 10 to the minus third meters, or 1,000th of a meter. 1 over 1,000, 1 over 10 to the third. So make sure you know your metric prefixes, okay? I won't provide them to you, but you will have to convert between different prefixes on the test. We're going to use dimensional analysis. On this first test, you'll have particular questions that are just testing to see if you can do the dimensional analysis. It's algebra, basically, that you're looking at units and simplifying them algebraically and telling me, are those units consistent throughout an entire equation? And so I'll do several examples for you, and then I'll allow you to do some as well. But first, before I do that, let me just give you some common dimensions and units. So for example, for area, when we're measuring area, it's going to have units of meter squared. Volume, we have units of meters cubed, or cubic meters, we might call that. Velocity has units of meters per second. And then acceleration, which is a velocity per unit time, has units of meters per second squared. In the next chapter, we're going to deal with these more, and you'll get more accustomed to these. But for now, before we get into that chapter, I'll just give you these units, and then we'll use it for the next exercises. Also, let me give you units for x. X, we use that as a measure of position. And this is given in units of meters. And time, which we use the variable t, is given in units of seconds. All right, so now let me ask you this question. I'll do the first couple, and then I'll have you do the third one. Are these equations dimensionally correct? The way, when I pose this question to you, and you'll have this question on the first exam, what you do is you put in the units for each of the variables, and then you look at each side and see if those units are consistent. So for example, you might be able to look at this first one and tell me whether or not it's dimensionally correct without even writing anything down. What do y'all think? Is it dimensionally correct or not? That is, are the units of this side, x, or position, consistent with the units on this side? This is velocity times time. Are those consistent? Well, let's take a look and see. So x is in meters, and v and t, v is meters per second, t is seconds, And now I can cancel out or simplify. I can cancel those seconds. Sometimes when I'm doing these, this one's a little more straightforward, but sometimes when I'm doing like more complicated ones, I might write it like this. I might say meters over 1 equals meters over seconds times seconds over 1. That'll write everything as a fraction. That way I don't get confused about what's in the denominator and the numerator. It depends how strong your math skills are. If you got good math skills, then you probably don't need to do that. But, you know, a lot of us don't, so that's okay. We'll just move forward with what we know. Let me do this second one, and then I'll let you do the third one. So here I have x. It's in meters. This variable has a little 0 subscript. What that means is it's an initial position. So anytime I see a variable with a 0 subscript, that just means what is that variable at the initial time or at the beginning of my measurement. We'll see that more next chapter. Let me turn down this volume a bit. All right. Can y'all hear me through the speaker still? In the back? So x naught, which is our initial position, it still has units of meters. V naught, which is our initial velocity, is meters per second. T is seconds. And then I have this 1/2. Whenever I have a constant in my equation, it doesn't have any units at all. So as I'm dealing with this variable, I just take this 1/2 out. I just don't rewrite it at all because it doesn't have any units. It's just a number. A is acceleration. That is meters per second squared. And then T is seconds, but notice that T is squared. So now I want to ask myself the question, is this equation dimensionally correct? Is it dimensionally correct? And we're going to use our clickers. If you think yes, it is correct, then you put A. If you think B, it's not correct, then you put B. Or if you think it's not correct, put B. If you think it is correct, put A. If you think it's not correct, put B. What you want to check is the units of every individual term exactly the same? If they are exactly the same, the units of every individual term, then it's dimensionally correct. It doesn't mean that the equation is correct necessarily, but at least the dimensions work out correct. The units all work out correctly. So are the units consistent throughout every term in that equation? And we're going to stop at 53. 53. Okay, good. A is right. It is correct. I have meters, my seconds and my second squared cancel out, so I have meters all throughout this entire equation. It would only need one term to be different, and then it would not be dimensionally correct. So for example, if one of them had meters squared instead of meters, then that would not be dimensionally correct. Why don't y'all go ahead and give it a go for C. Just take a moment, take about 30 seconds, and start this one. You want to write in each term with its individual units. And then I'm going to jump in and help you a bit. All right, let me just sort of step in here. So V is meters per second. A is meters per second squared. Watch how I'm going to do this. This will help a lot of you because I know some of you don't have very good algebra skills. I'm going to write 1 over T as 1 over seconds. Kind of like I did up here, but now I'm doing it down here. And then I have the 0.5, no units at all, right? X is meters, T is seconds. And now I can go through and ask myself the question, is this dimensionally correct or not? You tell me, is it A? Yes, it is dimensionally correct, or B, it's not dimensionally correct. A, yes, or B, no. Do the terms of this equation all match? Are they all the same? The units of each term in this equation. Does this have the same units as this and the same units as this? All right, let's stop at 35. 35. Listen, when I'm asking these clicker questions, I'll give you a few more seconds. When I'm asking these clicker questions, feel free to talk to your neighbors. In fact, I encourage you to talk to your neighbors. Hey, sit next to somebody that always gets them right, and then you'll always get them right. Okay? So I encourage you to discuss the question with one another, even if it's just checking your answer. Let's stop at 53, okay? Hey, look at y'all. B is right. All right, so I have meters per second cubed plus meter seconds. None of these match up. Hey, listen, I was reading in the paper this morning. I was in the Advocate. Anybody get the Advocate? No, I get it. I guess I didn't catch this. There was this guy in this accident. His entire left side of his body was cut off, like his left arm and his left leg. Did you hear about that? He's all right now. Listen, when you get about 90% on clicker questions, you get a free joke for the day. And then you can go and tell your friends. And they'll think that you're cooler than you are. So, not that you're not cool. If you didn't get it, just see me afterwards. I'll explain. All right, let's try this one. This is from an old test. There's a typo here. V should say meters per second. This was a little more complicated than the ones we've been doing, but I'll show you how it can be greatly simplified when I show you these. Feel free to discuss with your neighbor how they're doing it. I mean, you can just like answer this. Right now the class is sort of evenly split between A and B. One of the answers. Let's try to wrap up in about 15 seconds. I know that 3 minutes might seem short, or 2:30 or so might seem short, but on a test, that's what you're shooting for. Because you'll have 25 questions to complete in about an hour, or a little more than 25 questions. So you do the math, right? You need to be checking through those questions. And you'll be practiced enough, so don't sweat that. I'm going to stop here in just a few seconds at 2:43. 2:43. Okay, we were sort of split. Let's see. There's an easy way and there's a hard way to do this. Let me show you the hard way. The hard way is just doing it the way that we've been doing it. So I have meters, that's X. I have meters per second squared, that's A. I have M, that's kilograms. And then I have 1 over seconds. And then I also have m, which is kilograms. I have v, which is meters per second, but it's squared, so I have to square both of those. I have a, which is meters per second squared, and then I have v, but you have to take the reciprocal of it, so it was meters per second, now it's going to be seconds over meters. So that's sort of the hard way to do this, and I would get meters cubed, kilogram over second cubed. Over here I would get, I can cancel some things here. I would get kilogram meter squared per second cubed. So that doesn't work out correctly, right? My meters are wrong. However, there is an easier way to do this. Let me show you. I can just take a look at this equation right off the bat and just simplify it without actually putting in the variables. What are some things that I can cancel out? I can cancel out a v, right? I can get rid of this v because I have v squared over v. I can get rid of something else as well. Anybody know? I can get rid of two something else's. A, I can get rid of a because it can't on either side. I just divide the entire thing through by the acceleration. And then similarly, I can get rid of the mass, m. I get rid of the half, and so I get x over t equals v. Oh, it should have been right, actually. Did I do something wrong here? On which side? Oh, you're right, Savannah. Right, so this, sorry about that. This should be meters squared. All right? You'll see my mistake here. Nobody said anything. M times n is meters squared. So they actually are, in fact, dimensionally correct. So let's, sorry, 60% warrants not a joke. We'll do some more of those as we have some other clicker questions that we'll do. So you'll get extra practice. In the homework, there's practice. On every old exam that you see, you'll see questions like that for extra practice. It takes practice. It's algebra, largely. And if you're really good at algebra, then you probably have no trouble. But, you know, you probably have to practice some. All right, let's talk about uncertainty. In the lab, you'll talk a bit about uncertainty. You have to calculate systematic and random uncertainties when you do the lab this week, or I think all of you have it this week. We'll just sort of talk about it briefly here. Whenever you make a measurement, you have some uncertainty in that measurement. And that's important for you biologists, especially because you do a lot of measurements, right? And you need to understand what the uncertainty is, how to calculate it, and what it means. And y'all calculate it in the lab. When you have a set of measurements, you can take the uncertainty in those measurements. The uncertainty tells you how well you know about you. So for example, if I report an uncertainty for x as 4.5 plus or minus 0.2, that means, so it depends how I report my uncertainty, but that means as far as we're concerned that the value x can have a value anywhere from 4.3 to 4.7. All right, that's what this plus or minus means. You've probably seen uncertainty reported in this way, but it means that there's a range of values over which x can has a valid measurement, has a valid value for it, that you just don't know what it is. It's not exactly 4.5, it's somewhere in that range. That's all we're really going to say about uncertainty now. As I said, you guys will do that more in lab in more detail. And as you get into some of your higher level classes, even in biology, you should be studying that as well. Okay, so significant figures. You'll have some questions on the exam that are just specific to significant figures. And then throughout the semester, as you see questions on the exam, they'll have correct significant figures. But this is really the only time in this class that you'll be tested on sig figs. All right, a significant figure is a reliably known digit. It just tells you how well you know a number. I have a video I want to show you. So take a moment here. I want you to write down the number of sig for each of these numbers, and then I'll step in. So just fill out this middle column. How many sig figs does each of these numbers have? 0.1, how many digits does that have? It has 1, right? Only the 1 here. This is just a placeholder. 0.0054, how many does it have? It has 2. Right, so it has 2 sig figs. These are our sig figs. 102, how many? It has 3. What about the 0? That's a reliably known digit. It has 3. It's not a placeholder. 100.1, 4. 100.007, it has 6, and 0.0054 is 0. That's 3. That's very good. The 5, the 4, and that last 0 are reliably known digits. If you ever have a question, you can write in scientific notation, and in scientific notation, all the digits that you write are sig figs. So this would be 1 times 10 to the minus 1. This would be 5.4 times 10 to the minus, what? 3. This is 1.02 times 10 to the 2. 1.001. There are 4 digits there. Times 10 to the 2. 1.00007. And then this is 5.40 times 10 to the minus 3. Sorry guys, I'm still trying to get the sound system set up here. When you write numbers in scientific notation, all of the digits are significant. All right, now on your test, you're going to have questions that are like this, that when you're either multiplying or dividing or when you're adding or subtracting, you'll probably just have one question maybe 2. Not very many, but you need to know, you don't want to miss any. When you're multiplying or dividing, you want to use the lowest number of significant figures. So for example here, if I were to do this in my calculator or just in my head, I get 410.2. However, when I'm multiplying or dividing numbers, I want to keep the lowest number of significant figures. So here I have 4 significant figures, and here I only have 1 significant figure. So really the correct way to write this number would not be 410.2, it would be what? 400 is right. And here if I do this value, 8.25 times 5.1, I get 42.075. How would I write that number with correct significant figures? I would get 42, because I have 3 sig figs here, I have 2 here, so I just keep 2 significant figures for the final answer. It's important as scientists, whether you're a physicist or an astronomer or a biologist, that you write your numbers, your measurements, with the appropriate number of significant figures. That would be 42. That's when multiplying or dividing, you use the lowest number of sig figs. When you're adding or subtracting, use the smallest number of decimal places. When multiplying or dividing, use the lowest number of sig figs. When adding or subtracting, use the lowest number of decimal places. So for example, here, I would write 132.7. If you did that in your calculator in your head or whatever, that's what you would write. However, that's not correct because I have no decimal places here and only 1 here, 0 and 1. So instead, I would write this as 133. I would have no decimal places represented in my final answer. And when rounding, and this is true for your grade too, if you have an 89.5, that's a 90. If you have an 89.4, that's an 89. And so this, for example, would be an A. And this, for example, would be a B. Okay? That's how I round. Some of your professors might round differently. But I want to see the smiley face, right? I know y'all do too. B's good too, though, right? C is actually pretty good as well. But that's how I round numbers. In general, and this is what you'll see on your test, is you'll see a question like this where you have mixed addition, multiplication, and division. And in general, you keep the proper number of sig figs for each step as you do order of operations. So in this expression, which steps would I do first? Would I do my addition, or my multiplication, or my division? I do either the multiplication or the division, or do them both at the same time, in fact. So, for example, I would do this step, keeping proper number of sig figs. Then I would do this step, keeping proper number of sig figs. And then I would do this step, keeping proper number of sig figs. So you have 3 different steps. Let me step you through each of them. So 3 over 4.2. If I do this in my calculator, this is 0.714, but I would just write it as 0.7 plus 2 times 6.75. If I do this, I get 13.5, but I just keep one significant figure, so I'll write 10, and then I would add those two together. If I added them together, I'd get 10.7, but keeping no decimal places, I would write the answer as 11. So that would be the right answer there. And I would give you a set number of answers, or I'd give you a range of answers, and you would have to choose one that had the proper number of significant figures. I think I have an example on the next page. I do. Now let's try this. Which answer has the appropriate significant figures for this mathematical operation? Don't worry about, you don't need your calculator, because if you put in your calculator, you're going to do this. Okay, really you want to look at it and ask, how many sig figs do I keep with this operation? And then how many sig figs do I keep with this operation? And your final answer will have the appropriate number of significant figures. If you finish this one, you can go on to the next one, and I'll be putting your clicker thing up for that soon. Feel free to ask your neighbor what they put. You can check your answer. And we'll do about 10 more seconds. About 1:45. I'll go to 1:48. Some of y'all don't have clickers, is that right? Yeah. If you don't have your clicker, just get it as soon as you can. Like I said, it's okay for you to miss a couple days here and there, but we don't want to start out not having your clicker. All right, A is right. Again, I don't need my calculator. I just look at this and I say, this has 2 significant figures. This has 1 significant figure. So the result of this operation is going to have 1 significant figure. And then I'll have 1 significant figure divided by 2 significant figures. So my final answer will only have 1 significant figure. Let's try this next one. Consider this expression. How many sig figs should the final answer have? You might want to actually write out the operations here and actually figure out what the answer is. Well, you probably don't need your calculator. You know, pre-med students, on the MCAT, they don't allow calculators. You know that, right? And the math ain't easy on the MCAT. So it's a good practice. You'll be allowed to use calculators on the exam. But in class, try not to use them when you can. Make estimates about things and try to do the math in your set. It'll help prepare you for that MCAT. Feel free to ask your neighbor what they put. Doing a little better on this one than we did on the last one. Good job. Keep it up. That's a harder question even. All right, let's stop at 150. 150. Just a few more seconds. Just guess if you don't know. And indeed, with the clicker questions, you get credit whether you get them right or wrong. If you get them right, you get double credit, okay? But even if you get them wrong, you still get half credit for that problem. So even if you're not sure of the answer, make sure that you're putting something in. Let's see, a lot of you put B, and B is right. 4.1 plus 0.920, that's equivalent to 5.0 squared over 2.54. Oh, but why did I do that first, the addition? I did it because it's inside parentheses, right? I followed my order of operations. 5.0 squared, it has two significant figures, so I keep two significant figures, 5.0 times 5.0, so I get 25 divided by 2.54. And now I'm doing division. If I do this, I would record my answer as 10, but you say, oh, that just has one significant figure, right? It should really have two. And the way I represent that the 0 is significant, is I put a decimal point right here. Right, that was that line in the video about the decimal point dropping. If I divide these and round properly, I get 10. But it has two significant figures, and so when I represent it, I write it with a decimal point at the end. All right, so 2 is the right answer. Good job on that one. That was good. Those are old test questions, so those are the types of questions that you should expect to see. You'll also see some conversion of units, but you're going to see conversion of units all throughout the semester. Well, I'll give you one unit and you need to convert it to something else. It's pretty straightforward, but sometimes students have difficulty with it. So if you need extra practice with this, look at the homework, look at the old exams. Hey, come see me. I can make up some problems for you right on the spot. For dimensional analysis, or for these unit conversions, it's a lot like what we did with dimensional analysis, that we're just looking at the units and analyzing the dimensions. So say, for example, we wanted to convert 28 meters per second to miles per hour. The first thing that we need to know is we need to know what are the conversion factors. So if we want to go from from seconds to hours, we need to know how many seconds are in an hour. Well, there are 60 seconds in a minute, 60 minutes in an hour. So there are 3,600 seconds in 1 minute. And then 1 mile, does anybody know how many meters are in a mile? Let me think. How many meters are in a mile? I know if I go around the track, how many times around the track to get to a mile? I go 4 times. And that track is how many meters? It's 400 meter track. So a mile is about 1,600 meters. It's actually 1,609 meters. Because it's not exactly 4 times around, it's like 4 times around and then a little extra. All right, so that's 1,609. Now, I like to set up my conversion factors now. So I would say 28 meters per second. And first, I'm going to convert my distances. I would put my 1,609 in the denominator and my 1 mile in the numerator. The reason that I know to put them where they are is because it cancels out the meters. And so now if I multiply this out, I'll get units that are in miles per second. But really I want miles per hour, so I'll do another unit conversion factor. Does the hour go in the numerator or the denominator? It goes in the denominator. I would put 1 hour right here and 3,600 seconds right here. I know that they go where they go because the seconds have to cancel with the seconds. And so I cancel out those seconds, and I look at my remaining units. My remaining units are miles per hour, and that's what I want. And then I calculate that out, and I've done that. I get 62.6 miles per hour. All right? Now, this brings up an important point about significant figures, because you're probably saying, hey, you only have one significant figure right here. Isn't that what you're saying? So really, you should have one significant figure here. That's what you're thinking, isn't it? No? That's good, because unit conversion factors, they have like an infinite number of significant features. It's actually, in fact, we don't even consider conversion factors when we're considering significant features, because it's as if I could write not 1 mile, but I could write 1.0000 and on for all infinity. That's a perfectly known number. So it has an infinite number of significant features. Okay, so the number here that has the lowest number of sig figs, infinity, 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 3. Okay? You follow me? You don't consider conversion factors when you're doing sig figs. Converting units with powers, you'll probably have a question on the test where you have to do just this. It's just straight up, what is this in these new units? Goodness, God bless you. So for example, let's say I want to convert 5.7 kilograms per cubic meter to grams per cubic centimeter. So there are now 2 conversions that I want to do. These are within the metric system. I'm going from kilograms to grams and meters to centimeters. But I also have this pesky little cube in here, which is going to make it a little more complicated. So we'll do a similar thing. I would say 5.7 kilograms per cubic meter. I know that from my metric prefixes that 1 kilogram is equal to 10 to the third meters, or grams rather, and 1 centimeter is equal to 10 to the minus 2 meters. That's from my metric prefix list. You'll get the knack for these, like they'll be more common to you later. But these are from our metric conversions, our metric prefixes, which you just need to know. A good way to do that is write them on a note card or whatever and tape it to your kitchen cupboard or your bathroom mirror, just somewhere where you'll see it for, say, a week, and then you'll have them down like that. You'll also encounter them in your homework problems, and that'll help you understand them better, or memorize them better. Okay, so now I put in my conversion factors. I have 1 kilogram here, and 10 to the third grams. And then over here, I have 10 to the minus 2 meters divided by 1 centimeter. I multiply these out, and I look at my units. So let's go through and just check our units. I have kilograms here, and it leaves me with grams. But then I come over here, and I want to cancel out the meters. Does it cancel out with the meters in the denominator? No. So whenever you have units that are to a power, a cube or a square or whatever, you have to cube that unit conversion factor. So that now I get cubic meters up here and cubic centimeters down here. I cubed that whole thing. So then these units would cancel out with this. And then I'd be left with grams per cubic centimeter. Okay? When you're doing unit conversions with powers, you have to, if you have one of your units that is raised to a certain power, you have to raise your unit conversion factor also to that power. Otherwise, your dimensional analysis doesn't work out. Your units don't work out in the end. And so that works out to be 5.7 times 10 to the minus 3 grams per cubic centimeter. All right. Anybody ever been to Boston? Been to Boston? There's a bridge across the river there, the St. Charles River, going into MIT. Nobody? Anyway, that bridge is measured in smoots, and because MIT students are dorks, and they have some fraternity, and they take this guy and they measure the bridge in smoots. That's his height. Like they make him lay down, and they lay down across the entire bridge, and then figure out how many smoots he is. And they have paint marks on there. This is 1 smoot. This is 2 smoots, and they're about 5 or 6 feet long. So you can have units that are just funky like that they're not part of any system. And the bridge over the St. Charles River is that way, measured in smoots. So let's say that we know that the unit conversion factor is this, that bridge is a little more than a football field long, 125 meters long, and it measures out to be 364.4 smoots. That's how long the bridge is in meters and in smoots. I can use that, that's like a unit conversion factor, to determine how many smoots is some other bridge that's 225 meters. And so I'd say 225 times 125, 364.4, and that works out to be 656 joules. Let's see, did I do my, yeah, I did my unit version, right, or my sig figs. So you can have funky units like that too. We don't encounter that very often. If you ever go to Boston, go visit the bridge and take a picture of the paint marks on there. George Smoot actually won the Nobel Prize for some of his work that he did in physics. And so he is the person after which this bridge was named, or this measurement system. All right. Let's do a few more quicker questions. Now, these are in your workbook. Deandra, can I borrow your workbook? Deandra, right? You can take it and you can flip all the way to the back and flip back a few pages and you'll see these questions. If you get to the always and you've gone too far. You see these questions, they'll look like this. Okay? I mean, everyone flip it to the end. Oh, I'm sorry. They're a little out of order. If you have to go to the second page, and you'll see these questions. And so you can follow along there and write down the answers. I will post the answers to these when we're done with these questions. I'll post them to the website. On the website, there's a link called Concept Test, and you'll find these with the answers on them under Concept Test. It's not so important for this one, but for others it is. So let's try this, just sort of reviewing some of the stuff that we've done. The standard meter since 1983 has been determined by which of the following? Which of these is the standard for the meter? A bar in France, the wavelength of light, distance from the equator to the North Pole, or the distance that light travels in that amount of time? Ask your friend. We won't take long on these. Hopefully you can answer them as quickly as you can read them. I'm going to stop at 50 seconds. 50. Just about 5 more seconds. And again, this is practice for the exam because you want to be able, these conceptual questions, you want to be able to answer them as quickly as you can read them. I'm going to stop here at 55. Okay, awesome. D is right. Remember, it's based on the speed of light, which is really the ideal for a standard of measurement, that it's based on some physical constant. What about the second? The standard definition for the second of time is based on which of these today? Frequency of cesium, average solar day, sidereal day, or is it Greenwich Civil Time? Stop at 35. 35. Okay, awesome. A is right. It's based on this characteristic frequency. It's a physical constant. The frequency of that cesium atom never changes, and so it makes for a nice standard definition. Mass, along with what other two quantities make up the three basic quantities in mechanics, which is what we've been talking about, to derive additional quantities. Mass, what, and what? Length and force, power and force, length and time, or force and time. All right, let's do a few more seconds. Let's go to 45, 45. Hey, look at y'all. It's mass, length, and time. It's the MKS system. Meters, kilograms, seconds, mass, length, and time. Hey, first of all, if you're offended by poor language, then I'm sorry. You're just going to have to live with it. You can clog up your ears. Okay? What did the fish say when he ran into the concrete wall? And this is where he'll say, I don't know what. Damn. That's a good one, isn't it? All right, so if the displacement of an object x is related to velocity, by this relation, x is equal to a times v, where x is displacement or distance in meters, v is speed or velocity in meters per second, then a has the dimension of which of the following? If x is equal to a times v, then what are the units for a? X is in meters, v is in meters per second. So it's similar to what we've done before, but it's also a little different. You'll see that red writing in the back? Okay, good. All right, let's stop at 125. 125. Okay, C is right, because I have meters here, I have meters per second here, and so I want to know what units must A be in order to make these two sides the same. A has to be seconds, so that when you cancel them out, you get meters on both sides. Okay? You'll see similar questions in the old exams and in the homework questions, which are at the back of your chapter. Let's try this one. A crate has these dimensions. Try to do this without your calculator. If you just have to, that's fine, but try to do it without, because it's certainly doable. Has dimensions 1 by 1.2 by 0.8, and then there are 3.28 feet per meter. What is the volume in cubic feet? First, you'll find the volume in cubic meters, and then convert it to cubic feet. But you can round off numbers. You can get to the answer without using your calculator. I'm going to help you out a little bit because we're almost out of time. Our volume is approximately 1 cubic meter. It's not exactly, but it's approximately 1 cubic meter. And a meter is approximately 3 feet. So I want to convert that now to cubic feet. All right. Y'all are doing well. One of you, a group of you are getting it right, and then a group of you are getting it wrong. Let me show you the answer right now so we can go. 1 cubic meter times 1 meter, 3 feet. But don't forget I have to cube this. So it's actually going to be 1 times 3 cubed, which is 27. And then you would choose the one that is closest to that. So it's going to be A is the right answer. Go ahead and put A and everybody get it right. And then I will see you on Friday. We're going to finish this up. Hold on a second. That homework assignment is very important. Okay, if you Friday at midnight, don't put it off till Friday at midnight. Okay, make sure you're working on it. You'll find that they're not that difficult, I think. But you might run into some problems. If you do, please come see me, or ask a neighbor, or ask somebody else. You have a great day. Well, y'all look at game. You gonna win? Yeah, we are. Yeah, you are. What's up? Okay. No. I'm sorry. I also posted. Okay. Okay, great. Have a good day. Okay. Yeah. Yeah, email me. Great. What's your name? Emily. Emily, okay. I'm wondering about the honors period. Yeah. Brett, you have to, I have some ideas online for honors credit, or if you have your own ideas, you can do so, but I have to see your proposal before I can sign. Okay. I don't think this is due for some time anyway. Do you know what
I think it's September 1st or 3rd.
Okay, well, take a look at that document online on the website, or also just let
It's
me
on
know.
Moodle?
It's on the website is linked from Moodle.
Okay.
Or you can, and then go to that website, and there's like honors
I
projects.
think I know it. I think
Yeah.
I've seen it there.
And then, or if you have another idea, then by all means, share it with me.
Okay.
And-
Thank you.
Okay? Did I say that in class? Are you in the online class? Oh, right. So, what's your name? Haley. Wonderful.